Okay, everyone, we're going to move on into chapter 11, which deals with a topic known as exception handling. And the first kind of thing you need to get a grasp on is what is an exception, and there, once you know what an exception is, then we can begin to understand what exception handling is. So you can see one of the first thing that I have here is an explanation, some theory, if you will, about what an exception is. So, there are three categories of errors, and you guys are familiar with at least some of them. When you're thinking about an error, what type of error have we talked about before?
Syntax.
Okay, a syntax error. Okay, a logic error, and a runtime error. Perfect. Okay, now a syntax. Thank you. When you have a syntax error, your code doesn't compile. Right? So you're missing a comma, you're missing a quote, a semicolon. You've got a method that accepts 3 parameters, but you're not passing it anything. That's the syntax error. A logic error is when maybe you multiply instead of, you meant to divide, right? So you make a mistake with the math, most likely, that gives you bad results in your program. So your program will run, it'll give you the output, but the output is incorrect in the real world. Therefore, you made a mistake or someone made a mistake logically. And a runtime error. And a runtime error, really a logic error can produce a runtime error because the program is actually running. But another thing that's generated from a runtime error is an exception. All right, so a runtime error can generate an exception. And here's what I mean by that. Have you ever asked the user for a number and then accidentally, accidentally typed a letter? Okay, what does that do to your program?
It crashes.
It crashes. Yep, crashes the program. So that's what an exception does. And we say crash. The textbook would say abruptly ends the program. Right? So that's what an exception does. An exception is a runtime error that terminates your program. It does. It crashes. It's no longer running on your computer. Here's another scenario that causes a runtime error. Can you guys think of any off the top of your head?
You have like the subscript for an array that's out of bounds.
Access an array subscript that doesn't exist. So you have an array that has 5 elements in it, and you try to say, my array sub 5 equals 10. Well, that doesn't work because the indexes go from 0 to 4. The index of 5 doesn't exist, so this would actually cause an exception to occur. AKA, your program would crash with an error message that would say something like this. The error message would say, an exception has occurred, man, at line 45, and they might say array out of bounds exception at line, something like this. I don't memorize these error messages, but they do tell you some sort of message that, hey, we have an array out of bounds exception. That's the type of exception that has occurred. In C#, there are over 100 exception classes. So learning exception handling is a process by which you're learning the different type of exceptions that can occur. It's easy to say, okay, you're asking for input and they give you a letter. That's one type of exception. Array out of bounds, that might be a type of exception. If you take a glance at page 491 in the textbook, which this is currently the 6th edition of, Visual C# 2015. If you look at that page, there are, I don't know, 15 or so classes so that you can begin to get familiar with the different errors, the different runtime errors, aka exceptions, that can occur in C# that can cause your program to crash. Now, I really like how the book put this, and so I'm going to mention this here. Managing exceptions, okay? Or you could say handling exceptions. Managing or handling exceptions means that you cause the program not to crash. You stop the program from crashing. Managing exceptions involves an oxymoron, because you must expect the unexpected. You must expect the unexpected. When you ask the user for a number, your program asks the user for a number. You shouldn't expect them to give you a letter, right? Now, because we're getting into programming, we're learning to expect the unexpected because we've done it on accident. It's actually, I don't know, 1 in 10 chances that any one of us accidentally type a letter instead of a number, right? So naturally, when you're asking for a number, it doesn't make sense to expect them to type a letter. But as programmers, we have to begin to expect the unexpected. And the more you work with exceptions, the more you work with these exception classes, the better you'll become at doing this, right? The more you understand the type of exceptions that can occur, the better you'll become at predicting or expecting the unexpected. So it's not going to happen in one night. You're not going to just read this chapter one time and become an experienced exception handler. It's going to take some experience. It's going to take getting familiar with these 100 different exception classes. Okay? And here's something else that I'll put out there that's not in the textbook. You might go work for a company, and we're going to talk about this here in a little bit, You might go work for a company and they don't use exception handling. Okay, there are reasons that you might not use exception handling. Okay, here's something that as I was studying this, one of my friends went to go work for the United States Postal Service, USPS. Okay, he was a programmer, and I think he worked in Java. And I was asking him some different questions, and I got, asking about some exceptions, and he says, we simply don't handle exceptions. I said, what do you mean you don't handle? He goes, we just let the program crash. Okay, so in his scenario, they let the program crash, they open the program again, and they let the user type in the information again, and they just start over. Now, some programs, I mean, you think about this, some programs are more critical than others to keep running. Okay, I'll give you a perfect example. My mother, she works in the hospital. She's a nurse. Okay, and what she does is she monitors patients remotely. So she doesn't go to the bedside nurse. She's not the bedside nurse, but she's a nurse that sits behind about 9 computer screens, and she looks at different patients at different parts of the United States and monitors what's going on. And if any of those patients, if any of their get into a critical status or their numbers start dropping, they need attention, she'll call the local nurse in to their room. Okay, but what she does is she monitors patients remotely. Now she monitors patients remotely through an application. This application is tracking vital signs for someone's life or death. Okay, that's a type of application that you don't want crashing. Okay, that's a type of application that needs to stay running even if there's a runtime error. Okay, so comparing that application to the Postal Service application, where they would just say, no, we don't use exception handling, not just because it's a matter of the program crashing and having to re-enter it, but also I would tell you that through my experience, I've noticed exception handling, especially when I've worked on this stuff 15, 20 years ago. When I first started doing exception handling on older computers, I would notice my computer would run slow when it hit some of this code. Okay, so exception handling is a little bit of a performance downgrade to be able to do some of these, to be able to write this code. Now, I don't know if you guys are going to experience that because our machines are a heck of a lot faster than 15, 20 years ago when I first started doing this stuff, but I'm just telling you, I noticed a difference. Okay, so getting back to this, the different types of exceptions, well, again, I can refer you to page 491, and I'll just try and pick out maybe some of the ones to begin to get familiar with. Argument exception, when you try and pass an invalid number of arguments to a method. Arithmetic exception. We're gonna work with this one here in a little bit when I do my demonstration. We're gonna attempt to maybe divide by 0, or it says casting or conversion you try and convert something that you can't convert. You try and convert a string like the letter L into a number. You might get that type of exception. Let me look. Oh, IO exception. You can kind of notice the format here, that kind of what type of exception comes first, and then the word exception comes after, just letting you know it's a class, it's an exception class. IO exception, that's when you're working with files. Maybe you try and write to your file to the hard drive, but the hard drive is full, right? Or maybe you try and read something from the database, but the database is corrupt, right? That's an input or output exception. This is one that used to be thrown a lot in the old days. I remember I remember when I studied computers and my teacher would talk about, oh, I had, so many bytes of RAM or whatever. One of my first computers, I had 128K of RAM. Kilobytes, yeah.
It's pretty crazy.
Yeah. And I upgraded it to 256. Right? So I put another 128K stick in it. You don't see out of memory exceptions too much anymore. But in the old days, you try and run a program that you didn't have the memory to run, you get out of memory exception. Okay, so those kinds of things would run.
How is that kind of thing handled?
It would crash the program.
Can't do anything. You
Can't do anything.
To,
Yeah.
Get rid of anything.
Oh, I'm sorry. How would you actually handle that?
Yeah.
Okay, well, if it was within your program's control, then you could handle some memory management, like clearing old variables, cleaning up your application's space. It's the operating system's job to manage the total memory management, but it was your job to manage your application. So you might be able to delete some old memory out of your application. I like this one just by the name. Man, Stack Overflow exception.
I hate that.
I do too.
This is, and I'm reading the book out of here, thrown when the exception stack overflows because it contains too many nested method calls. I'm going to read that again. Thrown when the execution stack overflows because it contains too many nested method calls. Too many nested method calls. I don't know of any sort of limit, like you can only call so many methods, so I'm going to have to come back and I just like the name because of the website Stack Overflow. Anyways, so there's lots of types of exceptions. Getting familiar with the common ones is a good idea. You're going to get familiar with them through the labs and through the exercises. Because we now understand inheritance, all these 100 exception classes, they all essentially come from 2, and I say, okay, 3, I guess. They all come from essentially 2, but then those 2 have one parent. So you could say that all of them come from 3 classes because these 2, they both have the same parent. So all 100 of these extend from SystemException. That's all of these that are the predefined exception classes. Okay, so the ones that I wrote here, these are predefined and they inherit from SystemException. We're going to discuss at some point in this chapter user-defined, which when you have user-defined exception classes, we're creating them, in other words. They extend from, or they should extend from, application exception. And this is user-defined exception classes. Okay, so really, I think the easy way to think about it is, okay, all the predefined, meaning the 100 built-in classes, they all come from here. They're all inherited from here. If you create a class that's an exception class, it can come from application exception. Now both system and application, both system exception and application exception have the exception parent class. So that's why I say, okay, exceptions really, they derive from these two, system exception and application exception. But both these two classes inherit from the exception parent class. All right, so this is just all theory. Understanding exceptions, understanding there's a lot of different predefined exception classes, understanding their hierarchy a little bit. Now as we become, you know, more experienced programmers, when we study a new class, it helps to understand its inheritance hierarchy. So very frequently you'll study a class, and then you want to understand how it inherits, what's its hierarchy. Because as you understand the hierarchy, that will help you understand more about that class. Okay, so that's going to be kind of a common thing that you begin as you're continuing to study and become a better programmer. Here's a class, here's its hierarchy. Okay, and the next thing I wanted to do was purposely generate a system exception. And remember, a system exception, that's right here, right? That's one that's going to be built in a predefined exception class. So we're going to purposely generate a system exception here. So I'm going to write some code, and I can do an abbreviated version of what's in the book. Double results equals some number divided by 0. And okay, so it doesn't let you just hard code this in. At least it's smart enough to recognize that. So I'm just going to create a instead of dividing by 0, because it wouldn't compile there, but if I get some user input, that's the denominator, right? Please provide the denominator. Now, if I run this, please provide the denominator. Okay, so not only does my exception hand up, I get this demo has stopped working, a problem caused, a lot of times you've seen this, this error in different programs, whether it's your video game you're playing or Microsoft Word, it crashes. A lot of times you probably don't get to see the actual error message unless you're in the command prompt. Maybe sometimes you do. A lot of times what they do is they write the exception in a log. Like they log it in your Windows log or your application log or your system log in Windows. Instead of notifying the user, all they get, because users don't know. Think about this for a second. If you told this to a user, unhandled exception, system divide by 0 exception, attempt to divide by 0. First off, I don't think most users would look at that. And if they do, they might read about this far and then give up. Say, I don't know what the heck's going on. And then if they continued, they might get it here. But again, it goes back to that old saying of you have to program for the dumbest users, not the smartest ones, right? So anyways, point being, they're not going to know what the heck this is. But you could see a system divide by 0 exception has occurred, crashes your program, close the program, close it out. Now, a couple ways, and one, you already know how to handle this. There's traditional error handling, which is techniques you've already learned. You know, if the denominator is 0, then don't do the math. Just using an if-else kind of statement. And put a loop in there and continue to get the denominator until it's a positive number. That right there, using loops and conditional statements, that is traditional error handling. Okay? Traditional error handling can handle some of these problems. Maybe not all of them, but many of them. And then sometimes you might use object-oriented error handling, which is another technique that we'll talk about here in a little bit. But let's compare it using we'll solve it using traditional, and we'll solve it using object-oriented. So let's start with traditional. So traditional error handling might look something like this. Okay, so if we're trying to prevent them from dividing by 0, again, I'm just going to cut this here and put this all under traditional error handling, because that's what we're doing now. Well, we now have a loop that keeps looping while num equals 0. It's going to keep asking for the denominator, and not until we get a different number. And I'm going to just add this in here. So we get a double divided by an int, and we get a double in the result. So if we run this, you'll see you already knew this technique. Matter of fact, there was this part of your hands-on test yesterday. And if I say 50, we could, well, I guess the first thing to notice is it didn't have the exception, right? Because it's not dividing by 0. But just to demonstrate the output to the screen, you get the output of 250 to the screen. So that's your traditional error handling. Let me comment that out and show you another way using exception handling. When I say using exception handling, that is the object-oriented approach. So the object-oriented approach is to use exception handling. Now we haven't done this yet, so this is out all this theory to say, okay, this is how you do exception handling. Okay, here's our problem where we've got this problem where we might be dividing by 0, and put this line in here, excuse me, undo that, paste it here. Okay, so this is the old problem that we started with. Now, the object-oriented approach uses what's called a try-catch block. And so the first block is called try. And with the try block is where you expect the exception to occur. Like it's the line of code where you think the exception is happening at. In this case, when we divide by 0, this is the particular line. These lines weren't causing any problems. It was this line that was causing the exception to occur. Okay? And you can see the little compiler error there saying expected a catch or finally. So the try block is where you expect the exception to occur. The catch block is where you handle the exception. And let me type a catch block. And inside the catch block, you put the exception class that you expect to be thrown. This is when an exception occurs. When an exception occurs, it is, I don't know how to say this, it is said to be thrown. That's how we say it, right? An exception has been thrown. An exception has occurred. So an exception has been thrown in the try block. So a catch block is where you handle the exception that has been thrown. In this case, we're expecting a divide by 0 exception to occur, to be thrown. So this is your class, and you'll have a variable, and I'll just call my variable EX. Now, EX is a variable of this class. So inside of the catch block, I can use that variable and I can access its properties or its methods. You can see there's a message, there's a stack trace that we'll talk about. There's a ToString method. But for now, if this exception occurs, what I'll do is, instead of maybe doing like a loop or anything like that, and instead of crashing the program, I'll just give a nice console.write line. You cannot divide by 0. Please run the program again. And then console dot goodbye. So you can see that the program will not, first off, it doesn't give a nasty error message. It gives a very user-friendly error message, especially when you compare it to before. And then you'll see, instead of terminating the program where it crashes and stops running, it ends, or it continues normally until it ends. It no longer crashes and is no longer running in your system. Now if I run this, debug, start without debugging. If I do attempt to put 0 in there, it just says bye. Now it didn't actually give it didn't crash, but it did not run my catch block. And that's not what I was expecting. 1 second here, let me do this again. Let me just try debugging. Debug, start debugging. and we'll see why. Please provide the denominator. I'll type 0. Result equals 500 divided by num, which is 0. You can see right now the result is considered to be infinity. It just doesn't catch it.
Yeah.
Well, I know it does have a green squiggly. Let me pause this recording and figure this out real quick.
Maybe we need like different exception type.
So after a little bit of troubleshooting, I'd say about 3 or 4 minutes of troubleshooting, we did find the culprit here. Essentially, our exception had stopped being thrown. Our exception altogether was not being thrown. And what we found out originally, if I just Control-Z everything back, here's our little bit of troubleshooting that we did. This is where we left off essentially. Actually, I had a friendly, I didn't have this in here. Okay, this is where we left off. And to fix the problem, we found out that the exception was no longer, it wasn't being thrown at all, because this exception, remember these exception classes are pre-built, meaning they have a predefined time when they're thrown. Okay? We don't control when they're thrown, they just are thrown under certain scenarios. I learned today, and my class learned through this exercise, that when you have a double divided by 0, the exception is not thrown. However, if you have an integer, an int divided by 0, now I run this. Now we get the catch block. The catch block says you cannot divide by 0. Please run the program again. And then we see that our program terminates normally. It just continues running. And it could continue running forever until, but ours just doesn't have anything else, and so it ends. Okay? So it's kind of a quirky little thing that I learned here, is that when you have an integer divided by 0, that's when that exception is thrown. You just saw I didn't even use the EX object. Now if I wanted to, instead of saying this friendly, I could say EX dot, and here's a message property, right? So I'm just going to write line the message property and then say goodbye. Let's see what that says. Okay, that's actually pretty similar. Attempted to divide by 0, goodbye.
So every exception has a message.
Every exception has a message. Yep. Now what I might do here is, if this works in the try block, I'll okay, now let's see how this works. If I just say 2, well, there you go. You get your normal. The result is 250. So you could see that the try block would execute. It would skip the catch block completely because the exception doesn't get thrown, and it would write goodbye. In addition to the message property, there's another ToString. Because we learned about ToString and we learned about inheritance, we know that ToString gets inherited. And so in this divide by 0 exception class, whoever wrote it, whenever they wrote it, they overrode the ToString method and they overrode the message property. Let's see how they overrode this one. See, the ToString actually gives you a little bit more detailed information about your exception. So this actually looks kind of similar to the program just crashing anyways, but it tells you a little bit more. For example, this happens in the main method, so that might be useful to a programmer to know that this exception actually occurred in main. Now right now everything's going on in main, but when you have method calling another method, calling another method, calling another method, it might help to know the method that actually threw the exception. It even tells you line number 75. See that? So ToString tells you information that from a programming standpoint you could use to troubleshoot the exception. This comes in when your program's crashing, you don't know why, you want to figure out where and how and what exception, that kind of thing. Now, this is a specific class that we're catching, but watch what happens. Let's see, because we know that there's this exception parent class, and we know that a parent can be a child can be upcasted into a parent. Like in our last chapter 9, we said animal equals new cat and that kind of thing. So it actually works out where a parent can catch a child. So we know that divide by 0 is a child of exception. So divide by 0 is underneath exception in the hierarchy. Let's see if this can be caught. Okay, and it actually works out where the ToString tells you exactly what's going on. Divide by 0 exception. It tells you that even the class that caused the problem. So if I didn't know what exception is being thrown, I could use exception EX, use the ToString, and because of inheritance, it can actually give us some detailed information here. Let's see how detailed the message is. Same thing. So the question that might come up at this point is, well, Mr. G, why wouldn't we just always catch exception EX? You know, why do you have to know the specific divide by 0 exception in all the other 100 classes? Well, making it simple, but also it is more efficient processing wise to catch a specific class than it is a generic.
There's like multiple different exceptions that can occur, and there you want to do different things.
And there's another scenario. Now, right now we're only dealing with throwing one exception, but what if this try block has multiple different exceptions that it could throw? So you want to have different results based on the exception that's thrown. Okay, and that is something that we're going to do in the later video. We're going to have one try block that throws multiple exceptions, but I think that's another really good answer as to why might we need to catch specific exceptions instead of always just capturing exception EX, is because what happens when this try block has two different exceptions that it can throw, and you want to handle them differently based on the scenario.
Like what you were doing before when you're trying 500.0, doing a double divided by, with that's another exception, I'm sure. You just didn't know what it was called.
Right. All right, so we already demonstrated the ToString method up above, and that comes from exception class. So I think that's a good place to kind of stop the video here, and we'll do another video tomorrow and finish up these lectures, and you guys are into labs. Thanks for watching.